Alright guys, I decided to make my own video for this lesson. I'm kind of excited actually. I haven't given a math lesson in a while, so let's see how it goes. So we're in week 4, lesson 1. Today I want to talk about axis symmetry, vertex, and Y-intercept, and we're specifically talking about parabolas. Okay? Parabolas. Let's close that. Okay, let's talk about what we know so far. So far, we definitely know what a quadratic is. We know that there's different forms of quadratics, but to start out with, we talked about simplifying, and that's adding and subtracting and like grouping the like terms, and then we talked about going from linear to quadratic by multiplying, and that was distributing or box method. We also talked about factoring. Factoring was going from standard form to factored form, and we did that with the process called factoring. Okay. And then most recently we talked about the roots, the zeros, the solutions, the x-intercepts. Those things have a lot of different names, but it's all talking about the same thing. Where does the parabola cross the x-axis? We can use factored form to find the x-intercepts. We can use quadratic form, especially if you run into some quadratics that are not factorable, which is what we're going to be talking about today as well. And then discriminants tell us how many roots there are, but we don't really know like what they are from the discriminant. We have to use the whole quadratic formula. Okay? Alright, that's what we got so far. So here, I want you guys to take a second and think about what are the a, b, and c values for this quadratic here. We should know that the a value here is -1, b value here is 6, and then the c value here is +1. And we know that because of the coefficients here. Okay, so next thing I want to ask and see if we can clarify is if the parabola is going to open up or down. And take a second, think about it, Ed Puzzle. Let's pop up a question here. Whether it's going to open up or down depends completely on that leading coefficient of a. In this case, a equals -1. We wrote that on the previous slide as well. A equals -1 means our parabola is going to open down, and it's going to have an upside down U shape, a sad face shape. Will the parabola have a maximum or minimum? Well, if we know it's going to be this upside down shape, or upside down U shape, that means that it's going to have a highest point up here. It's going to have a maximum for this particular example because of that leading coefficient of -1. Okay, so now here's what it looks like. Here is, we see it opening down. We see, yeah, I mean, that's pretty much what we see. We see a couple of key points there. But one thing I want us to ask ourselves is, can this quadratic be factored? And we're just basing that on a couple of things. First of all, the expression, and then over here, the roots. Now this root looks like it's close to 0, and this root looks like it's close to 2, 4, 6 there. But I mean, it's hard to be precise when you're just looking at Desmos. I mean, this is a screenshot, but if I needed to, I could zoom in, and you guys know Desmos has all kinds of cool tricks for us. But let's think about it from a factoring standpoint. If I needed a -1 here and a 6 here, there is no way that's going to happen, right? I can't multiply two numbers to get 1, but add them to get 6. It's just not going to work. So let's look at what those key points that are with Desmos. Like we said, close to 0, but I mean, that's not a number I'm familiar with. Neither is 6.162. But what else do we notice? We notice a couple of key points here. This point is the 0.01, and this point is the 0.310. Those are nice numbers that I can work with, and those are the points that we are going to focus on for today. So even if you run across a quadratic that's not factorable, we still have things we can learn about the parabola and about the quadratic to help us figure out what the parabola looks like. Okay, so let's see what else we can talk about. We haven't really talked about the symmetry of a parabola yet, but the truth is, Parabolas are symmetric. They're U-shapes. So there is a line, an invisible line that goes straight up and down the middle of the parabola that we call the axis of symmetry. And that's another characteristic of a parabola that we can identify if we're trying to learn some things about the parabola. One of the things I like is how the x-coordinate of the vertex always matches the formula for the axis of symmetry, because if it goes straight down, it's going to hit the x-axis with a matching coordinate of that vertex, because it's a vertical line. That's quality of vertical lines. So let's see. Axis of symmetry. Here's the definition you can write in your notes. What is it? It's a line about which a parabola is symmetric, and that's the line where the parabola reflects on itself. It's a vertical line, and we are always going to use x equals when we're talking about axis of symmetry, okay? So, first find the A, oops, let me switch colors, so I'm going to have something a little bit brighter. First find the A, B, and C values. We practiced that earlier. Now, for axis of symmetry, you don't really need the C, but I mean, we know it's there anyways, but for the equation for axis of symmetry, you are going to take negative b, or the opposite of b, over 2 times a. And that is going to give you the x-coordinate of your axis of symmetry. Okay, negative b over 2a. Let's practice it with this one. This one had a 6 for b, so that means I would be doing negative 6 over 2 times negative 1. That's negative 6 over negative 2. That's a 3, and it matches. It also matches the equation for this vertical line is x equals 3. And we said that we always use x equals for axis of symmetry equations. Okay. Now that leads us to finding what that vertex is, the y-coordinate. Now thanks to Desmos, I know it's going to be a 10. But if I didn't have Desmos, I need a strategy. So what is it? It is the point at which the parabola intersects the axis of symmetry. It's going to be an xy coordinate form. It's either maximum or minimum depending on if the parabola opens up or down. We practiced that earlier. Okay, so how do we find it? First, find the axis of symmetry. I'm going to abbreviate that AOS. Okay, and it's going to be some x equals. Then substitute or plug in negative b over 2a, whatever value you get there, plug that into the function. So really what you have is you have negative b over 2a, and then you're going to find, what do I get when I plug in negative b over 2a? And that will give you your x and your y. Let's try it over here. I already know that my negative b over 2a is 3. We just practiced that on the previous slide. Let's plug in 3 and make sure that we get the 10 that we know we should get. Oops, plus 1. Well, this is negative 3 squared, so that's negative 9 plus 18 plus 1. Negative 9 plus 18, that's going to be a positive 9. And then plus another 1, that gives me the 10, and that matches the y-coordinate. Okay, so let's find your axis of symmetry. Plug into your quadratic, and that'll give you your y. For your vertex, put it all together, coordinate form, you got your vertex coordinate. Okay, another thing that we were able to see thanks to Desmos, but we need to be able to find even if we don't have Desmos, is the y-intercept. Hopefully you remember that term. Y-intercept just means where does this curve, in this case it's a curve, sometimes it's a line, where does this parabola intersect the y-axis? Now what we do for that is just plug in 0, right? Because anywhere on the y-axis, x is going to be equal to 0. So plug in that 0 and see what happens. So I'm just going to write plug in 0 and simplify. Let's see what happens here. I like plugging in 0 because everything just kind of disappears and you're just left with that C term. So another thing you can think of is the C term is going to help you find your y-intercept as well. All right. Now let's put it all together. I'm going to do an example, and hopefully this example helps you with your homework as well. I'm going to also pick up on this example with tomorrow's lesson. Just so that way we have some like continuity. You can see me do the same problem from different aspects, because that's what I'm going to have you do on the homework as well, okay? That's a separate video. Let's do this example. X squared minus 4x minus 3. Oops, sorry, plus 4x minus 3. Okay, so we need, first of all, we need to figure out if this opens up or down. Based on that A term, I'm going to say opens up. If it opens up, that means it has a minimum. Let's find that axis of symmetry. We need to find, it's going to be x equals negative b. Well, this happens to be a 4, so I'm going to want a negative 4. If this had already been a negative 4, I'd have plugged a positive 4. Over 2 times a is 1. Love that, because now it's just negative 4 over 2. And I know that's negative 2. So axis symmetry, x equals negative 2. Now let's use that to find the vertex, because I know that I have to plug in x equals negative 2, and that'll give me my y coordinate. So, excuse me, 4 times negative 2 minus 3. Here I have positive 4 minus 8 minus 3. Well, 4 minus 8 is going to be negative 4. Minus 3 more is going to give me a negative 7. So my vertex is going to be at negative 2 for x, negative 7 for y. All right, let's finish up by finding that y-intercept. Remember, we just plug in 0, so I'm going to have 0 squared plus 4 times 0 minus 3. Well, those disappear. I just have negative 3. So my y-intercept is going to be the coordinate 0, negative 3. Okay, and we just learned 3 things about this parabola: axis of symmetry, vertex, and y-intercept. Now we can get a general idea of the placement of the parabola on the coordinate grid, but that's going to be saved for next lesson. We'll discuss domain and range on next lesson, and then we'll start sketching these things. For now, I just want us to focus on those 3 characteristics and sketching for the next time. Okay, email me if you need me. You guys know the deal. Take care. Hope you're having a good week. Hope you're finding some balance amongst all your classes, and really taking care of yourself. All right? I'll talk to you soon. Bye.